Good afternoon, everyone. Welcome to the second UKSTT webinar. This time round, we're going to be touching on underground utility detection and location. Within the viewing platform, the bar at the bottom has both Q&A sections along with a chat section. If I could ask that all questions are put into the Q&A tab, I'll try and address these at the end if we've got any time left. So, my name is Andy Gundry. I work for Plowman Craven. I'm the operations manager for the utility survey department. I've worked in the utility industry for almost 15 years, having begun my career as a mechanical and electrical engineering quantity surveyor. I'm now responsible for the operations within the utility survey department here at Plowman Craven. For me, it's all about trying to save lives. If we've got something wrong and somebody hits a power cable, this could result in some life-changing occurrences, if not worse. So Plowman Craven is the UK largest chartered geomatics company in operation for over 50 years. We have internally several departments. So we've got property development, which is associated with topographical surveys. We have MBS, measured building surveys, infrastructure, which is a rail team implementing the use of UAVs. We have my utilities department with a strong team of 15 working on prestigious projects from the Palace of Westminster through Thames Tideway and Elephant and Castle. And finally, we have a BIM department, which is the only, within that, we are the UK only survey company to be awarded the BSI ISO 19650 kite mark. We are Thames Water approved, we are Achilles accredited, and also UVDB. This webinar will provide an introduction to PAS 128, the varying levels of specification and how it aligns with HSG 47, the equipment that can be used during a survey, and the importance of obtaining accurate information. We'll be addressing the applications of the surveys, the equipment that we use, and like I said at the beginning, if anyone has any questions, just pop them into the Q&A section, and I'll try and answer them at the end for you. So PAS, the publicly available specification 128 of 2014, is a guidance on how to conduct a survey or to produce an output and how to have confidence in the results as an end user. It aids in focusing on the information available before works on site commence, ensuring all utility record plans are present on site, referencing industry guidance, as an example, HSG 47. It aids in the ability to undertake high-quality PAS 128 level surveys to locate assets, including the use of appropriate locators through the pre-construction phase. It gives us an awareness of the potential inaccuracies of statutory record drawings. It assists with designing out risk where possible. And it also gives the relevant information that can be fed back to the asset owners for more informed location as not to plan. The recent PAS 256 guidance for reporting such assets is a recommendation in line with as-built. Briefly, it covers the installation of new assets and how to record them and update documentation as the handover or adoption is carried out. So PAS, it focuses on 4 elements and methodologies of a survey. They range between a type A and a type D. So type A is a physical excavation. So you visually observe an asset in location. Type B is by locating the utilities using 2 methods of detection whilst on site. Type C is reconnaissance. which gives a visual drawing of a picture of networks from features such as scars, covers, or marker posts. Type D is desktop. It's asset records from service providers or asset owners. These are a key part of all aspects of PAS survey, and for any survey to be compliant, these must be available prior to any site visit. It's essential that the survey team have an awareness of what is in the ground to ensure all final outputs identify the potential hazards. So the PAS aims to provide, the PAS aims to provide clarity in the service provided and the methods employed, consistency in the approach to data capture, classification of the results and the confidence that can be associated with them, standardization of the format of deliverables, and accountability for the work being undertaken. It applies to the detection, verification, and location of active, abandoned, redundant, or unknown underground utilities, and the location of the associated surface features, i.e. manhole covers, utility markers, stop taps, valves. It applies regardless of where these utilities are located. It applies to utilities buried no deeper than 3 meters. So moving on to the tables that can be found within the documentation. Currently in the industry, there is still a large misconception as to what a PAS 128 survey defines. Majority of the end users or clients apply what PAS 128 as to define a confidence level. So for example, an end user inquiring about a utility survey would ask for a QLB 1P survey. When in actual fact, the classification applied, QLB 1P, is assigned post-survey based on survey number of survey, based on number of survey methods the asset was detected or located by. So as a surveyor or practitioner, is to determine the quality level from that site work and post-process data and varying levels of confidence that can be given to any one line. As mentioned previously, this relates to survey type A and D. Type C and D are standalone levels. They refer to lines not traced, so taken from record drawings or visually placed on site. They have no level of accuracy in regards to horizontal or vertical depth. Type A, albeit a standalone quality level, as the asset is physically visualized on site, horizontal and vertical location can be applied to the data in the form of a manual measurement or observed with survey instrumentation, with tolerances of 50 millimeter horizontally and 25 millimeters vertically. Type B comes with further suffixes. So after the B, there is numbers 1 to 4. The 1 to 4 depict the accuracy of that asset being found on site. So with a designation of B1, assets located by 2 methods of detection with a horizontal accuracy of plus or minus 150 millimeters, vertically 15, plus or minus 15% in relation to the depth. B2 is asset located by 1 method of detection with horizontal accuracy of 250 mil plus or minus of its detected depth and plus or minus 40% in relating to its vertical positioning. M3 is an asset located by 1 method of detection with a horizontal accuracy of plus or minus 500 millimeters. In this instance, it more refers to the passive or the passive sweeps carried out by receivers. So usually you will find that, I'll use radio detection as an example. They may have power or radio mode. These modes will detect magnetic fields within the ground and give you an approximate location of where they are. Because no signal is being transmitted through the asset or the anomaly, the equipment isn't capable of being able to pick up its depth. So that's why there's a wide tolerance of 500 mil in regards to its horizontal location. B4, the asset has not been located on site but is suspected to exist. This could refer to drainage. If a flexi wire is inserted and it's seen to be joining another chamber but unable to trace or locate with any other method, then this level can be applied as the route between the two covers is assumed. With majority of these levels, there is a final suffix which indicates if data has been post-processed. So this would have the letter P at the end of it, which just refers to the post-processed data. So this is where the data is brought back from Office, predominantly relates to GPR data. So it can be interrogated within an Office environment by a trained user or geophysicist. The data can be manipulated further to highlight certain aspects, removal of noise from features encountered on site, and in turn gives the capability to look for further subsurface features such as voids, ground movement, cracking, or obstructions in regards to concrete slabs or reinforcement. Moving through, we come across the methodologies. So these are the elements of a survey that the end user or client can specify. This depicts the level of detail they require along any one or all assets. As you can see from the table, the suffix P appears again. This is the client requesting that all data on site is post-processed in back office prior to delivery. The numbers associated with each methodology refer to the spacings of data to be shown and can be associated to a certain environment such as open wasteland or densely populated urban city centre environments. So going through the list, we have M1. This refers to EML or Cat and Jenny data depth and location to be measured and displayed within the output every 5 meters. Passive and active sweeps to be carried out every 10 meters. Until an anomaly is located, where it will then reduce back down to the 5 meter spacings. GPR grids to be formed at 5 meter centers unless multi-array antennas are being used. M2, same principles. The depth along a traced line by Cat and Jenny or EML is every 2 meters. Passive sweeps increase to 5 meters until that anomaly is located, where it reduces again, and GPR grids to be formed at 2 meters. M3, again, the data increases. So EML data depth and location is displayed every 1, passive and active sweeps every 2, and again, until further anomalies are located, and the GPR grids to be set out at 1 meters. And finally, the more intensive survey, the M4, EML depth or Cat and Jenny, is to be detailed every ½ meter, so every 0.5, passive and active every 2, again until an anomaly is located where it reduces back down to 0.5, and GPR grids is to be set out at 0.5 meters for a more intense data coverage. In general, the more detail required from a survey, the more expensive that survey will become, as the information to be processed both on site and in office dramatically increases. HSG 47, which is a health and safety executive document, is issued as a guidance. So it outlines the potential dangers of working near underground services and gives advice on how to reduce any direct risks to people's health and safety, as well as the indirect risks arising through damage to services. This promotes the need to carry out underground utility surveys across all work sites, implementing PAS 128 that is going to improve the level of detail. It deals principally with the risk to health and safety rather than damage to services. However, precautions taken which reduce risks to people's health and safety will generally also reduce the risk of damage to services, which can directly or indirectly pose a risk to people's health and safety. The guidance is aimed at all those involved in commissioning, planning, managing and carrying out work on or near underground services, as well as the owners and operators of said services. Guideline industry recommendations is that you must always be aware when using equipment that is involved with more strikes and ensure that guidance is in place to mitigate the factors. Where hand digging, consider the guidelines given to staff, foot pressure only to reduce the number of incidents. Consider the protective equipment, such as insulated spades, if hand digging is unavoidable, and ensure appropriate PPE is worn by all employees. We need to consider the alternative excavation practices, so trenchless technology, no dig, vacuum excavation, the implementation of machine controls where necessary, and similar to reduce the risks. Consider the risk to operatives when using specific types of equipment. Although there is more control with hand tools, there is much higher risk of injury to personnel. Each contributor to consider their own results and working areas and to provide opinion, and work to the requirements of HSG 47 and follow safe dig practices as a minimum to reduce these incidents. So as an example, safe digging practices would be scanning the ground layer by layer throughout the excavation to ensure that there's no cables or ducts running below the site. So the majority of projects that would require references to HSG 47 and PAS 128 are, for example, borehole locations. 10-meter borehole needs to be installed. Needs to be drilled within a public footpath. Plowman, Craven, or any other survey company will come along and carry out a plant avoidance survey. So with a plant avoidance survey, there would be no specific deliverable. It would literally be a markup on the ground showing where all the anomalies or utility related features are, and the borehole would be positioned around them to avoid any damage. Horizontal directional drill, launch and receive pits, again plant avoidance whilst excavating both pits. Provision of a full utility survey, so topographical background, full survey across the site could assist in drill profiles to determine lines of shot to see how deep they need to go. We can also incorporate GPR to find out where the bedrock is to assist with the design. Mains installs or service installs, diversion routes, feasibility studies for the design of new connection routes, and access through congested areas, ensuring that guidelines are followed. So as an example, EHV need a safety zone, EHV cables, so extra high voltage cables need a safety zone on either side of them due to the temperatures that they might reach. I think it's about 1.5 meters in either direction before another asset can be installed. So the location of these cables is important when you're designing new networks in the area, so you can make sure that the asset that you're installing isn't going to be affected by the assets that are already existing. We can carry out surveys for load bearing, so we can provide depths of culverts, sewers. With GPR, we can cover the depth of the cover load for load bearing calculations. A survey can facilitate demolition, so we can locate the services that need to be disconnected or removed. And then as-built surveys, which slightly refers to PAS 256, but recording the installation of new assets as they're installed or surveying said assets that have already been backfilled and covered up. So to carry out all of those types of surveys, the equipment shown on the screen at the moment is predominantly the main bit of kit that we use as a survey company. This page covers the conductive assets. So these tools detect the conductive objects, either by the practitioner inducing their own signals into the asset or by inserting a foreign object into the pipe, which will either conduct its own signal or allow us to generate our own signals through it. When tracing cables, we use EML, electromagnetic locators, or Cat and Jenny, as they're commonly known. The Jenny part of the equipment allows us to induce a signal into the ground, which is picked up and carried by the metallic or conductive object. The receiver measures these signals, and with the internal antennas, allows us to calculate a depth. When tracing cables via Cat and Jenny or EML, the measurements are taken from the center core of that cable on the best case. When locating or detecting metallic pipes, as they're hollow, they can emit a signal from any point around its circumference. The larger the diameter, the larger the tolerance of error when you're coming to draw it or model it in BIM. So extra care does need to be taken as this area of tolerance does increase. The other equipment displayed allows us to insert our own signals. So from the FlexiTrace or sonde, the sonde, which is the image in the top middle, emits its own signal. So it can be attached to the Flexi, which is an image in the top right, push down a duct or a drain. The only issue with the sonde, because it emits its own signal, there is a potential for it to bleed or cross bond to other assets above what we're trying to survey, giving false information or potentially mislead the practitioner from one asset to another if the data is not interpreted correctly. These options are not always practical due to the nature of the asset. These predominantly are used within drainage or empty plastic ducts, networks which have a tendency to backfill with silt or other debris. So another arsenal of equipment available to utility surveyors at GPRs or ground penetrating, ground probing radar. They vary in shapes and sizes and have a lot of other applications other than locating utilities, from void detection, layer analysis, depth of cover. So the daily drivers we use at Plowman Craven, represented as the little yellow lawnmowers, which is the top middle image. These are from IDS. So we use the IDS Operas or the IDS Duos. These have dual head sensors integrating a 250 megahertz and 700 megahertz antennas. It provides the largest dynamic range and depth penetration, but we are required to perform grids in line with the PAS 128 methodology. So that's M1 and M4. We collect and process said data dependent on the P suffix. Top right, we have the stream C, which is formed of a mass array of 34 antennas in 2 polarizations. This omits the need to form grids, but this process increases productivity and maximizes the amount of data collected on site. Because of the size of it, and it records data in both directions as you walk in a single line, that's why it omits the need for creating a grid format. It effectively does the grid itself. So the stream EM and the top left, although I am showing the Pegasus 2 unit there, again, this is a mass array of 40 antennas, which increases the capabilities from the stream C in 2 polarizations, improving efficiencies with the additional capability of the unit being towed by a vehicle up to 15 kilometers an hour, 10 miles an hour. Due to the speed this antenna can operate, it reduces the need of significant traffic management and complex setups or permits. A support vehicle is required to protect the slow-moving vehicle and the expensive equipment, but with the correct signage in Chapter 8 and out of working hours, it allows the survey to be completed cheaper and more efficiently. Finally, in the bottom left, Plowman Craven are one of 4 companies within the UK that can offer the gyroscopic reduct system. This service omits the need to enter a sewer and traverse in traditional methods. We've carried out surveys up to 15 metres below the surface with 150mm accuracy in regards to the centre line. Using our own tried and tested methods, we do try to improve the health and safety of our teams and improve the innovational techniques to further advance our workload efficiency. It's also a highly recognised bit of kit in regards to Thames Water, as they do tend to prefer not to put a person walking down a sewer 15 metres below ground. So off the back of using all that equipment, we get a greater accuracy than not doing anything at all. The consequences involved with not carrying out a utility survey can range dramatically from gas strikes, gas explosions. As you can see, top left, there was a gas explosion. It's taken half a house out. Severe water leaks, cutting neighbourhoods off for hours, if not days. Cable strikes, bottom left-hand side, you can see what looks like an excavator has gone through another gas pipe or an electric main and caught fire. We do what we do in a survey industry to prevent these incidents. We always try and go along the non-excavation trenchless route. One, it reduces cost, but it also prevents incidents like you can see on the screen, so from burst water pipes to collapsed buildings or raging infernos. So that's the end. If anyone has got any questions, I will try and review them in the Q&A. Okay. If anyone does have any questions, if they contact Lynn at the UKSTT, I'd be more than happy to respond privately. I do thank you for everyone who attended, and hopefully I'll get to speak to you or see you all soon. Thank you very much.